of the excentral triangle is in fact the circle of the original triangle. So, i-check ko na lang I-check ko na lang
Very to,
kasi
very to scale
tama.
po eh. Very to scale.
Uh, uh, so, okay. So that takes care of uh ito. So that would be this. Okay. So September 28th, we started talking about homotheties. And then for today, hello. Okay, what's his name? Pangalan niya,
Ano
Joshua.
kasi?
Okay.
Wait lang po. Naalala ko.
Yan, Joshua. Siya si Joshua.
Ayun, Ross po yung pangalan niya.
Ross?
Apo.
I don't know Ross. Kilala ko si Joshua. Ayun. Ayan. Okay. So homotety is a transformation where the elements are you have a center, the center of homotety, and then a scaling factor, which could be a negative number even. And then we already explained the mechanism last time. And the nice thing about homotheties is that it preserves angles, tangencies, and circles. So what I'd like us to do today is a survey. Let's go through some problems. Now, these problems, they can be solved without using a homotherapy. What's nice with many problems is that you can solve them via different means. So let's also look at solutions which utilize the homotherapy inherent to the problem. So one of those problems that we saw already was from this. So you have the triangle ABC, and then why are those points concyclic? And when you form the circle out of them, that's the 9-point circle. So what are those points? So you have the red points, which are the feet of the altitudes, and then the blue points, which are the midpoints, and then the green points, which are halfway from the orthocenter going to each of the vertices. So why are those 9 points concyclic? It's because they are based on these 9 points from this larger circle, which is the circumcircle. And if you perform a homotety centered at H with scaling factor 1/2, then these points on the larger circle will be brought towards the 9 points that we just described. And so therefore, those 9 points are also going to be concyclic. Okay, tas may mga nakuha pa tayong bonus, which is that um, the center of the circumcircle is O, and if N is the center of the 9-point circle, then that means H to N results from a 1/2 homotherapy from H to O. So that means N is collinear with H and O, and furthermore, it's halfway between H and O. So the center of the 9-point circle N is in fact the midpoint of H and O. And the line through them is the Euler line. So at least in the Euler line, we know that there are 4 points that are special to the triangle: the orthocenter, the circumcenter, the centroid, and the center and of the 9-point circle. Okay.
Meron pa pong are there other points other than let's say po yung exciter point na nasa significant po?
So Euler line,
Apo.
I'm sure there are, or actually I don't know, but nothing comes to mind right now. Okay, kasi I'm sure there are lots of other centers that can be associated with any given triangle, and parang dami na ako, hindi ko na natatandaan lahat eh. So,
Meron
in
pong up
fact,
to
nung mga,
72,000.
what's that? Ano point yon?
72,000 mga triangle centers. Sa ano
Oh,
po,
wow.
updated po
Okay.
Kimberling's Encyclopedia of Triangle Centers.
Oh, may mga web page eh. May mga web page where they gather mga special sequences. Ito, web page where they gather special points related to a
Apo.
triangle. Mga centers, no?
Apo.
Okay. So parang syempre hindi mo na naman matatandaan lahat, but I suppose they appear prominently to those who are studying them because they satisfy certain nice properties. Okay. So ito example dito na tayo ngayon sa October. Hi. Hey there. Ito example. So you'll notice that these are exercises where we're not necessarily solving for any specific value. So the point is to come up with an argument. So ito, let the in circle of triangle ABC touch side BC at D, and let D H be a, wait, not H, because that might be mistaken for the orthocenter, so let's make it DJ be a diameter of the in circle. If line AJ meets BC at K, show that BD equals CK. Okay, so part of the goal is to, well, part of the task is to draw a nice enough figure. If pangit nung drawing,
Nice
then
enough.
nice enough, all right? Because I can't really commit to it being super nice. So I have a way out.
It has
So
to
here
be
you have.
it has to be to scale, otherwise there'll be
Okay,
consequences.
or no, the figure may or may not be drawn to scale. So if it's not drawn to scale, you can't sue me. Okay, so parang
Contract
ano,
law.
I just need the legal way out.
Contract. If it is if the triangle is not drawn to scale, then I will not be sued in very
Right,
small interest.
because I made no such promises. Okay. So we have the in circle of ABC. So, so lagyan natin ng konti. Wait. So before I let go, wait. Yeah. So pwede naman palang i-highlight. Okay, so this is D. Okay. And J, diameter of the in circle. Now the radius is going to be here, perpendicular to BC at D, because D is the point of tangency. So the diameter would be the continuation. So this would be J. Okay, medyo baliko ng DJ, but okay. Then line AJ
Parang hindi yata po
meets.
center ng circle yun.
Oo nga eh.
Use Thales' theorem to correctly pinpoint the
Okay. Ito lang. Sige.
Nice.
Okay. So let's say if this is the point of tangency, then ito. So ito mukhang center na, no?
Yan po.
Okay. So this is the, all right. So this is J. And then AJ meets side BC at K. Okay. So we're supposed to show that BD is equal to CK. Go figure. Okay. So I mean, they're supposed to be. So ito nung D, so B, D should be the same as
Olympiad
CK.
problems.
Oh, okay. Part of it is you gotta draw it nicely. Okay.
Hercom Kenter.
Okay. So what we see here is, at least from the point of view of J, parang something emanates from A going to J going to K. So they're
I
definitely
think
collinear. Okay.
I think with the center, wait lang, the in center. Oh wait. So D is reflected about the in center onto J. And then something from A. Something probably a homosity from A to from
Okay, yeah, for homotity from A. Kasi we see parang ano from A, parang nung J is mapped towards K, right? So
abo.
nung J, parang papunta siya sa K. But, well, so if the center of the homotity is A, then it's not just J that's going to be mapped to something else, but um,
A
no I.
yung the abo, the I will be mapped to
So, well, whatever I is going to be mapped to, it would have to be something that's collinear with A and the in center. Can you think of a special point that
an
we
X
know?
center.
Yes, an X center. Okay. And the X center is the center of an X circle. So ito. So I is the center of a circle.
Yes,
The
okay.
X center,
So the in center is mapped from A to the X circle.
wait, the in center is mapped to the
X center.
to the AX center. So I
Wait.
suppose
So
okay.
in this entire time, the X center was literally just magnified with respect to A, but it's the in
Yes.
center. What?
You see
Amazing.
that? Okay. Ito, sige, wrap up natin. So, ito. So, if we're gonna draw the X circle, so extend natin to. Okay. Tapos drawing natin no X circle, the AX circle.
Mhm. I hate angle bisector, so I will just use the circle tool.
Yeah, pero syempre spoiled tayo kasi we have technology.
On our side.
Otherwise, mag-drawing talaga na. Okay.
Literally. No. No.
Okay. Well, in the first place, it's not drawn to scale.
But
Okay,
yung other
so
side po.
bali nung argument natin, okay, consider the homotity which brings I to I sub A. So just so it's clear, the AX center. And thus, the okay. So kasi we know that
Not sorry about it looks like kung if you think about it, looks like a cone. Where there are two circular incisions, sort of. So kung meron pa pong homotity, diba in 3 dimensions?
is there a homotity in 3 dimensions? You know what? Why not? Why not? It's not something that I have encountered, but why not? Kasi when you have a homotity, kasi we're just talking about planar figures. So you have a collection of points in the plane, and then from the center, you just draw the line from the center to that particular point, and then you look at the image. But then that is something that can be done as well, even in a three-dimensional space.
Parang lens inisip ko Parang lens. Is that a homotity technically?
So, ano yan? Is that still a homotity?
It's
Is
sort
that
of
your question?
yung ano po kasi
And,
yung
and three, in three-dimensional space.
Abo.
Sa lens point sa lens.
Nung sa lens, well, I cannot, I'm afraid I'm not that familiar. Nung lens pa ginagawa is ano lang, parang pino-project lang.
Abo.
If that's what it does, then that's then if that's what it does, then it's a homotopy. Diba? I mean, diba? Kasi you get something similar to the original figure.
Abo.
So I guess that's it. So that would be, yeah. Even though you start with an image and then the projection is a flat image, pero it's just an image embedded in three-dimensional space. Yeah. Kasi you also have depth. Okay. So ito, consider the homotopy which brings I to I sub A. And thus the incircle, actually how about ano, which brings the incircle, so para mas general. To the A X circle. Okay. So, hold on. Okay. Yeah, where's the diameter? Okay. Okay. So this uses the fact that the reason why this is possible is because we know that I and I sub A are collinear with A. So I sub A. In fact, we already proved this last time. So parang nangyayari if you angle it differently. So you have a point, tapos ito merong circle, tapos when you apply the homotopy, so that produces a larger circle. So naturally, the centers are all going to be collinear. And then nung tangent at the small circle will extend towards a tangent to the larger circle as well. Kasi a homotopy perceives tangencies. Okay, so ito nung two-dimensional cone that you were talking about kanina, no? Okay. Tapos, so ngayon, i-consider din natin ano pa nung mga na maps. So if you have a particular point here, okay, so down from the smaller circle, it will be mapped to the corresponding point on the larger circle. So if you look at nung diameter ng small circle, it would be mapped towards a diameter of the larger circle as well. All right, so nung D, so ito. So dito siya mapupunta. All right. Tapos, so nung diameter, okay. Pero kasi, nung diameter DJ is perpendicular to BC, right? So therefore, what can we say about the image diameter? Kung vertical, nung small diameter, then the big diameter will also be perpendicular, because when you apply a homotopy, it does not change the slope, the inclination of lines and segments. So if the original diameter DJ is vertical, then the new diameter, the new in the context of the larger circle, it's also gonna be perpendicular to BC. Okay, perpendicular to BC, but then that image is K.
But actually, since it is tangent to BC.
Oh, so but then if IA to K is perpendicular to BC, what does that make of K?
Wait. So So if you map ano po, if you map yung ganun, if you map it that way, you can literally find the all of the x, you can literally find all of the x, yung x touch points sa mga ano mo.
Yeah,
So
oo.
you
So,
can determine the you can determine the x center without using angle bisectors.
in a way, yes. Oh. You're right. You're right. Oh, but actually, this works because we know that I and IA and also A are collinear. But kasi we know that by by proving that property of X centers, and it's based on how we define the X center in terms of
Ah,
perpendicular bisectors.
opo.
So in the end, naka-tie up pa rin yun, the fact that I sub A, parang ano, so background information, I sub A is the intersection of the external bisectors at B and C. Okay, but then other than that, okay, kunwari you're given A, B, and C, can we construct nung X center uh without drawing external bisectors? It turns out, oo, pwede na. So kasi ganito, gawin lang natin, halimbawa, nung I, na-determine, na-allergy ako. So nung I, na-draw na natin, no? Tapos i-drawing natin tong vertical diameter. And then now you have J. And then project J to where it meets BC, it would have to be point K. And then itong point K na to, from what we've done, K is necessarily an X touch point. So gawin na lang natin, once you have determined K, drawing ka ng line parallel to the diameter DJ. So you have a line, and you know the X center lies there. Then gawin natin, connect natin ng A with I and extend it, and where it meets this particular diameter, then that must be the X center. Okay, so I think that's what you were saying. Do we have a way of determining the location of I sub A without drawing external bisectors? Well, from what we did here, yes.
Nice. Opo.
Okay. Ito, pero sulat lang natin ng argument. Consider the homotopy which brings the in circle to the AX circle. Okay. It maps, okay, DJ, diameter DJ, to a diameter, okay, of this X circle. Since DJ is perpendicular to BC, then this diameter, okay, then this diameter, okay, is perpendicular to BC, okay, and then this makes, okay, K, which is the image of J, the X touch point on BC. Okay, so now that we have characterized, so ngayon, alam natin, K is, aside from being there on AJ, K is in fact the X touch point. And so do you now see why BD must be equal to CK? Kasi this was one of the properties that we proved. Let me point it out to you. We're talking about so andito lang siya sa September so that we don't have to go too far. It's one of the things. Ito. Do you see this? Itong figure here.
Na gel point, na tawag doon?
So kita mo nung purple
yes,
point is the point of tangency of the in circle, the orange point of tangency of the X circle from A. And then bale nung
Came into
distance from the
use.
orange point to a vertex.
Came into use.
Ito nung nagamit natin. So gets, kita mo S minus C, tapos ito also S minus C. From the vertex to the nearest touch point. Okay, so ito nung ano, so ginamit natin. Okay. And then for the wrap up, so use this fact, okay, that if you have ito nung triangle natin, and then this is the, okay, if ito nung X touch point, then nung, and then a point of tangency of the in circle, then this distance and this distance are equal. So if this is L, then that's also L. All right. So is it possible to prove BT equals KC without using homotheties? I'm sure it's possible. I'm sure it's possible. Okay, but I haven't necessarily thought about it. Ito, next example. Okay. Three
Tapos
circles.
ano po, yun nga po yung problem. Construct the X circle using compass and straight edge without using angle bisectors.
Yes. Oh. So actually, if you are familiar, if one's familiar with this, oh wait, without using angle bisectors, just be careful though, kasi
External bisectors, angle bisectors.
yes, because in the first place, you would have to draw the in circle, and to draw the in circle, you would need you would need the angle bisector at B and C, internal bisectors. So without drawing external angle bisectors.
Opo.
Or okay, yeah, gotcha. That's correct. Okay. Ito, next. Three congruent circles have a common point O and each is and each is wait, okay, let's try to make this more economical, but let me just go ahead and lie, not line, lie inside a triangle. Okay, each circle is tangent to two sides of the triangle. Okay. Prove that.
Why does the triangle have a little head?
Sige. Oh, sorry. Okay.
Para po siyang angstrom.
Yes, okay. You're right, no? Okay. Sige. Okay, so prove that the in-center and circumcenter of the triangle, okay, the triangle, are collinear
Hershey's Kisses.
with point O. Okay, now
What?
Mahirap i-drawing ito, but we're gonna start with 3 circles. Okay. 1 circle, then does it look like a circle? I want to fix
It looks a little fat.
how about this? Better?
A little emaciated.
Oh, yeah. Is there a way to modify the
Now it looks a little overweight. Ah, there,
how
okay na.
about this?
Okay na po yan.
Okay, no, no. All right, so this is what we're gonna copy.
Bro, copy paste moment.
Oh, okay,
There is not a single meeting without a copy paste.
of course. Okay, uh, and then so the configuration looks like this. So these 3 circles are they have a common point,
Radical
and
axis.
then pero ito. So let this pass through, but not necessarily like that. Pwedeng
Why does it
say
look like a
ganyan.
it should look like a Mitsubishi logo po.
Okay. But then we don't want to make it too symmetric. Okay. So okay, now you have so this would be 0.0. And then what we want to do, lines. Kasi each circle is tangent to 2 sides of the triangle. So this would be 1 side. Then all right, so we have our triangle. So all conditions so far are satisfied. So prove that that red point O, the incenter of the triangle, so let's call this A, B, C. The incenter and the circumcenter, that they are all that they're collinear. So ito nung O, and then in the same line that we're supposed to find the incenter and the circumcenter. IOC, International Olympic Committee. Okay. So
Ano po, it is yung Olympics logo minus the Audi logo plus 1 circle.
oh, Olympics minus I don't know how the Audi logo looks like. Is it parang 3 circles pa?
Apo.
Okay. That well, I suppose it's possible to prove this without a homotopy, but if we're gonna prove by homotopes, then well, there has to be a center of the homotopy. So ano kayang center of the homotopy ang gagamitin natin? I mean, we have 3 points. So is it a homotopy centered at I or at O or at C? And by the way, diba, if you have the center of the homotopy and then here is one particular point, when you apply the homotopy, it would be at a different point, which is, and then they're all collinear.
Apo.
Okay, so one of these is our candidate. Which one?
Okay, so the circles, it's funny because it is tangent to already two sides. Make it
Okay.
tangent to another side that is parallel to one of the sides. So then that circle would be the incircle of that triangle. Then it would be a homotopy from the vertex to the in circle of the actual triangle.
So you're thinking homotopy from. Oh, so you're talking about the in circle. Sige, sige. Try natin i-drawing in circle. And then
Underweight.
wait. No, because we already spent time
More
on each of these.
Bro,
Okay, and then let's change the color. Let's make it.
para lang po it's to cover the tracks of the copy paste. There.
And then let's make it. Hey, I'm supposed to change the color. Yeah. Let's make it
Gold.
orange.
Base colored.
Wait. First highlight, and then wait, it's supposed to change the color too.
Going to po space colored.
What space? Wait, first I gotta be able to change the color to begin with. Hold on.
Ano po? Me when the consequences of the sins are
Yeah, of copy paste. Ayun. Alright.
Space colored. Space colored.
Ang hirap naman makita kasi bluish din nung ano natin eh.
Yung gold po.
Gold. Alright, yeah, sige. I can live with that. That's fine. Okay. So, but then, so I suppose, okay, sige, we can take the in center value as the center of the homotopy, right? Kaso nga lang,
The vertices are the center of the homotopy. The
no,
circles.
so you're talking about three homotopies.
Yes.
Okay, so there's the homotopy.
There's a parallel line. Actually, the circles are already tangent to two of the circles. Two of the
Okay.
sides. So if you add the third side, which is parallel to the other sides, the other side that is not tangent to that circle, and since they are equally sized, are they equally sized?
Which one?
Circles
The
po.
circles? Yes, the circles are congruent.
Ayan, good. So it means it's not really the exact same identity. It's not the same homotopy, but all of them they will be parallel yung third side na a-add niyo po.
So all right. So halimbawa, I think I kind of get what you're getting. So for example, you have the for lack of a better term or just made up term. So you have the A circle and the B circle and the C circle, and then for the A circle, you're talking about ito parallel to BC, right?
Abo.
Okay, so parallel to BC, and then you also have to the B circle the tangent that's parallel to
If you notice
AC.
mo, then they will intersect all at O.
Not
wait, no,
necessarily. No, not necessarily.
Not necessarily. Okay.
Not necessarily. Yeah. Not necessarily, but since you're thinking about tangency, which comes from the I mean you already pointed out the in circle. Why don't we have a look at the in center?
It looks
Okay.
remarkably similar to O.
Alisin natin ng hold on. Oh, come on, please let me erase.
Ano po, when you accidentally make a small dot in one node.
Okay, I mean, I put it there.
It is too much, there's too much data to to erase.
Uh, well, okay, we do that.
What if you just selected what those the ones you want you erase and then just delete it?
Because I could, pero ang liit eh. Tingnan natin. See, I'll try next time. Anyways,
Shad.
okay. So the in center is gonna be where the angle bisectors intersect. So you have this B angle bisector, and then this is the A bisector. It seems like they're gonna intersect at O, which is not my intent, of course.
So then expand the image or something. Oh wait, no, that will change the circles. Oh,
So
oh they don't intersect at all.
so this is the in center I.
Oh
Okay.
no, how to
Ayun.
arrange the angle bisectors though?
Sige, iwanan natin ng angle bisectors. But, well, in the angle bisector through A, you're gonna see part of that segment is the center of that A circle.
Tang 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 tang. I think
The
that is
B center,
because nga po, it is the homotity of the in center, in circle. Because it's tangent to both sides and
oh, all right. So, pero wait, hold on. The in circle, we if we're gonna talk about homotity, dapat malinaw. What is parang a point is being mapped to which particular point?
the ano po, the tiny circles, they are tangent to both sides. So
Okay.
it is obviously a homotity po kung kasi kung from mapping that circle to the circle because it is still tangent to 2 points.
Okay.
Two lines A, B, and AC.
Okay. But hold on, I think we gotta clarify. So wait, you're about if you talk about the A circle, is that the image of the in circle?
Hindi
Okay,
po,
center at I.
in circle is the common image between the A circle, the B circle, and the C circle.
Okay, so you're talking about three homotheties.
Abo.
Three homotheties.
That all map to I. That all map to the in circle.
So homothety from A, homothety from B, homothety from C, and so therefore, kasi the A homothety will map the A circle to the in center. The B homothety will map the B circle to the in center. But because the A circle and the B circle have the same radius, and then under those two homotheties, the images will be the same. So that means the scale factors are the same.
Abo.
Okay, so the scale factors are the same. Although what that would give us would be, it would give us.
It also means po that the triangle formed by the little centers is directly similar to ABC because you can reverse po the homotety from the in center and then it will end up in ABC.
So actually, itong triangle na to, let's call this A prime, B prime, C prime. So you're claiming this is similar to ABC.
Abo.
Yeah, actually, also we can see that because, diba, ano to, this is the radius, and this is also equal to the radius. So B prime, C prime has the same distance. Well, B prime and C prime have the same distance from line BC.
And then also another observation po I would like to note. When you construct the perpendicular bisector of a segment, you put you draw two congruent circles from the two endpoints of the segment. and then
Mhm.
draw the radical axis. So finally,
And that would be the that would be the
the
perpendicular.
perpendicular
Ah,
bisector. And since they all intersect at O, it means O is the circumcenter of A prime, B prime, C prime.
okay. So got that. So bale ang so you're claiming now is that the circumcenter of ABC is the image of O with respect
With respect
to,
to I.
yes, actually that's it.
So now,
So that's why they're collinear.
the real, ano po, the real circumcenter is also, it's also collinear.
Okay, the real circumcenter of ABC. Okay. So
Nice.
yeah, actually that's it. So nung argument natin dito. So I suppose you could all frame this with I as the center of homotopy. Okay.
Abo.
Consider the homotopy, okay, which with center wait, hold on. So okay, since the three circles are congruent, okay, their centers A prime, B prime, C prime form a triangle whose sides are parallel to the sides of triangle A, B, C. And then because of the tangency condition, okay, A prime, B prime, C prime are on the corresponding angle bisectors of triangle ABC. So ibig sabihin, so nung A prime, I, so collinear sila, B prime, I, C prime, I. Okay, well, I suppose the fact that A prime, B prime, C prime has sides parallel to A, B, C means that A prime, B prime, C prime is the image of a homotopy based on ABC, and then the center would be where A prime, B prime, and C prime intersect. So that would mean the in-center I is the center of the homotopy. Okay, thus A prime, okay, triangle A prime, B prime, C prime is the image of triangle ABC under a homotopy with center I.
So yung tanong po dito, without using homotopy, kaya ba i-prove?
Yeah, so without using homotopes. So ano dyan, sorry?
Can you prove it po without using homotopy?
I'm sure pwede, kaso nga lang nung nung collinearity. Inisip ko, how would you prove the collinearity of IOMC without using homotopes? So paano kaya yun? Baka
Menelaus
gumamit ng angles or Menelaus theorem. But if you're gonna use Menelaus theorem, you're gonna have to construct a specific triangle. Tapos the 3 points IOC have to be specific intersection points. And then you would need to find lengths of segments if you're gonna use Menelaus theorem.
Use sort of an extended Menelaus theorem because those are angle bisectors. sort of like a Shevas theorem but using angles.
So parang nung trigonometric version of Shevas theorem.
Apo.
I'm not familiar with if there's a trigonometric version of Menelaus theorem. Is there? Not
But
that.
Menelaus theorem is just an inversion of of Shevas theorem. So therefore you could
Dapat
technically
merong trigonometric version, no? It stands to reason that there is a trig version. It's just something that I'm not familiar with. So I suppose they exploit the angle bisectors here. Okay. But anyway, as you pointed out, so the circumcenter, so anong mangyayari dito? Actually, if pwede natin i-argue, you were talking about how to draw the perpendicular bisector of A, B, C, if you're gonna look at the images of the three circles. But since we already have the three circles here, maybe pwede natin gawin, i-argue, O is the circumcenter. I suppose that's what you did. O is the circumcenter of A prime, B prime, C prime.
Apo, yun nga po.
Right?
Yun
Okay.
nga po yung ginawa ko po. O is the circumcenter. So therefore,
Okay.
ABC is just a mapping of A prime, B prime, C prime.
Okay.
Or A prime, B prime, C prime is the mapping. So and ABC is
Oh,
the big,
pwedeng baliktarin.
big thing. So therefore, they are collinear because it's just it's just a mapping.
Okay, so observe that O is the circumcenter of triangle A prime, B prime, C prime, since it is equidistant from A prime, B prime, C prime. So this is the relevance of the three circles intersecting at a point being concurrent at the point O. So ibig sabihin, A prime O is a radius, B prime O is a radius, C prime O, and then the circles are congruent, so they're the same. So therefore, O is equidistant from A prime, B prime, C prime, making it the circumcenter. Thus, okay, O is the image under this homothency of the circumcenter of triangle ABC. Thus, okay, O is collinear with the incenter and orthocenter. So that's it. An orthocenter of the triangle.
Therefore,
Of course,
this point is on the Euler line.
The incenter is not on the Euler line.
But yung orthocenter.
The orthocenter of kasi ang nasa Euler line, the orthocenter of A, B, C. But then this line we're talking about is the line which connects I and the orthocenter O of the triangle ABC. However, I may not be on the Euler line.
So it is
this
on
line
the Nagel line because the incenter and circumcenter are both present on the Nagel line.
Sorry, what's that?
Yung Nagel line.
Ano ulit ng Nagel line? You're gonna have to remind me. I keep on forgetting. It's
Yung
the
the Nagel point and the incenter determinant.
Okay, ano pa nung nasa Nagel line? The incenter and
Nagel point tsaka circumcenter yata.
if the circumcenter is there, then yes. Okay. Then yes, O would be on the Nagel line. I just don't remember which is which. Okay. So isa pang I'm trying to. Okay. How about maglagay na lang ako ng mga other exercises for you to try?
to try on your own.
Yeah,
Because
oo. Kasi tingin naman tayo sa
secondary
ibang ano na. I mean, we can discuss them next time. Okay, so let me write it down. Ito, sige. Okay, green triangle.
rock.
Let-
Secondary color composed of the colors of the approximate 500 nanometer wavelength and the 400 nanometer wavelength of a three-sided polygon with three-sided polygon in a three-sided polygon sheet
with
on 2 dimensions on an application known as OneNote made by Microsoft.
point of contact of the incircle
Hmm.
of triangle ABC.
So yung ano pa,
With-
Jergon points?
Sorry, what's that?
Yung Jergon points, yung mga in-touch points.
The point of concurrency of the in-touch points would be the Georgian point.
Apo,
Okay,
yung
nalilimutan ko.
yung in-touch points po, yung in-touch point po ng BC po.
Oh, so yeah, actually, so this is the in-touch point. So D is the in-touch point. I guess I could have stated it like so. So D is the in-touch point on side BC. Okay. Okay. If IO is parallel to BC.
Ano po yung O? Circumcenter?
Yeah, circumcenter and the in-center.
Mm.
So isusulat ko for clarity. If IO is parallel to BC, okay, show that. Okay, AO is parallel to HD. Here, I, O, and H are the in-center.
No!
Lahat sila magkakasama.
This
Circumcenter.
is literally mind-blowing because literally all of the three major
Oo.
excluding the centroid are involved. What if the
Are
centroid
the
is
center. All right. So here is what's going on. So you have triangle ABC. And then so ang primary condition dito is that IO and BC are parallel. So A, B, C. So let's say this is this is O. I hope mukhang perpendicular intersection to the perpendicular bisectors. Let's say this is the center of the incircle, I. So suppose that IO and BC are parallel. Show that AO. Oh wait, and then hold on. D is the point of contact of the incircle with side BC. So I is the in-center, so that means the in-touch point is here. So ito nung D. Okay, kasi you drop the perpendicular from the in-center to side BC, then you get the in-touch point. So in this case, prove that wait, H is the orthocenter. So ano siya, mga altitudes. And so that's the A altitude, and so this is the B altitude. So this seems to be H. So prove that AO and HD are parallel. Okay, and then of course figure not drawn to scale. Nga lang, mag-iisip tayo ng, I mean, if we're gonna do a homotopy, ano kayang ano? Wait, you know what? I forgot something when we were discussing the 9-point circle.
Axis of radicality.
Remember this claim number 2?
Raducanu.
Okay.
Wait, yes.
Hindi pa
Actually,
natin ito
pala,
nagawa.
I forgot. I was going to say something before. I already forgot. Is it something ba? It's about if you reflect the orthocenter ba on the in center or in center on the orthocenter. Basta it will end up on the B side BC or on the side. It will end up on the side.
Ano yun? If you reflect the orthocenter H.
If you reflect, hindi ko po alam eh. Basta if you reflect two important points, or the one important point on another important point, it will end up on a side. Parang ganun din po eh. Pero baka siguro homotopy lang po kaya yan.
But then, I guess, homotopy. I mean, if you got some proportional, may homotopy doon. But then when you look at the other sides, back the scale factors are different. So, ito ang nangyari nga, ano eh, M is the midpoint of BC, and then if you reflect H over M, and then say the reflection is P, then show that P is on the circumcircle. I mean, it's not trivially a conclusion that point P will happen to be on the circumcircle. So, ito nung claim number 2, I just remembered. Okay. And where exactly did we use this? Ito para sa ano, para sa kasi so we know that if you reflect the orthocenter H with respect to this foot of the altitude, so we've already, I think it's claim number 1, the reflection is going to be on the circumcircle. So it's that particular red point. So that's claim number 1. Ito H reflect over the foot of the altitude D. The result Q is on the circumcircle. Pero we also needed claim number 2 that if you reflect H naman over the midpoint M of BC, then the claim is that the reflection point P show that it's also going to be on the circumcircle. Okay. So, balikan natin siya dito. But why did I suddenly just think about this? Wala, natandaan ko eh. And otherwise, malilimutan natin to. Okay. So, prove natin to claim number 2.
But long after.
Long after.
We need to prove that how the 9-point center it's by homotopy. And then do something. But then you forgot claim number 2 a long time.
So a long time ago. So
Literally downfall of proof.
okay, so ganito. Extend HM to meet the circumcircle at P. So ang goal natin is to show that HM equals PM. Because if you're able to show this goal, that means you've shown that M is the midpoint. So that would mean P is indeed the reflection of H with respect to M. Okay, so I gave hints here because it's part of working backwards by observing that the foot of the altitude S, did I really call it S? Yes. We know kasi that the reflection of H with respect to S is Q. So HS equals SQ. Tapos if our goal is to show that HM equals PM, a consequence of that would be, also that would mean SM is a midline
SM
of triangle.
SM supermarket.
Oh, Schumart, Schumart. So that would mean again, SM would be a midline of triangle HQP. So that would mean SM would be parallel to QP. So if you have that 90-degree angle at S, so that would necessitate that 90-degree angle that I drew at point Q. All right, so parang we're working backwards, we're looking at the consequences. On the other hand naman, if Q has that 90-degree angle there, then that means AP is a diameter. Diba? That would mean AB is a diameter kasi you have the circle. You have the circle, and then if from here to here, you have a 90-degree angle, and dito ibig sabihin diameter itong what appears to be the hypotenuse. Okay, so related to the goal, we got to show that AP is a diameter. Yikes. May not be an easy thing to do. Okay. Gusto mo bang pag-isipan pa ulit to? Okay. Tapos balikan natin next time. Okay. So it's a reminder. Okay. Kasi right now, trying to think about it. So how do we show that AP is a diameter?
Similar triangles. Maybe there's a similar triangle. It's just hidden. Or there are congruent triangles that are hidden.
Ganito. We gotta start with anong definition natin? HM equals PM. Oh wait, hold on.
That is the goal.
Wait, extend HM to meet the circumcircle at P. How about let me rephrase this. Instead of, so I define P as the extension of HM as it meets the circumcircle. Let me change this. Reflect H with respect to M. So let P be the result. And then what we will do instead is show that P is on the circumcircle. So okay. So let's change our strategy. Okay, so proof. Okay, let P be the reflection of H with respect to M. Okay, so that we know for sure that HM equals MB. Okay, so ngayon ang question na lang natin, hindi natin alam if point P is on the circle. Okay, so ang goal natin, okay, show that P is on the circumcircle of triangle ABC. Okay, but here are some of the things going our way. Okay, because M is the midpoint of HP, that means, so right, immediately, okay, S and M are midpoints. Okay. So since HS equals SQ, and then HM equals MP, then SM is parallel to QP. Or consequently, okay, BC is parallel to QP. Kasi S and M are on BC. Okay. Another thing here is look at BHCP. Quadrilateral BHCP. What is true about that quadrilateral BHCP? What particular kind of quadrilateral is it?
I think it looks like a quadrilateral. It looks like a quadrilateral that has two parallel sides. It is a
yes.
really genuinely I forgot the term. Lexical
Trapezoid, kite, diamond.
I think it's a
Cyclic.
it's a tangential cyclic. It's a concentric quadrilateral.
It's an X touch point John Nagel quadrilateral. Okay.
Ayun, parallelogram.
Okay.
Lexical
Parallelogram. Oh, sige. So, but actually, yes, it's a parallelogram. What's an argument as to why it's a parallelogram?
I think it bisects both the diagonals are bisected.
Yes. So because the diagonals bisect each other, then that actually is enough to conclude it's a parallelogram. Note that, okay, BHCP is a parallelogram, okay, since its diagonals.
Kung parallelogram is parallel o gram figure, then why is a parallelepiped?
Actually, I don't know. I have no idea.
Why is it past tense?
Actually, I've been. That's one of the things that I have not found, or I didn't really actively set out to find an answer to that. With regards to the name, I think probably the first time I heard it mentioned, pronounced, I think I was in grade school. I remember hearing parallelepiped, and then at that point, I have heard of parallelograms, but what the heck is a parallelepiped or a? Well, actually, what I heard was parallelepiped. Huh? Alright, that's weird. That's new.
It should be a parallelopipe. Maybe.
So BHCP. I'm just winging it. I'm not sure. Ito. So okay, go. So try natin yan. What would it take to show that P is on the circle? Okay. Wait.
Isn't BHCP a disease or something? BHCP sounds like a disease.
Wait. I got it. Okay. Kasi ito. Remember? Okay.
Funny circle looking object.
Ito. If these 4 points are on the circle and you have those parallel segments, then what quadrilateral is formed?
An isosceles trapezoid.
Yes, isosceles trapezoid. So in fact, so ganito no, if you have a trapezoid that's inscribed in a circle, it's an isosceles trapezoid. Also, if you have an isosceles trapezoid, then that is a cyclic quadrilateral. So the fact is, I think we've touched upon this before, a trapezoid is isosceles if and only if it is cyclic, right?
Yeah.
Okay. Because now I'm looking at BCPQ. So we know that, we know that
So it must
QP
be
and
isosceles.
BC are parallel. So it
that's
must be an isosceles trapezoid. So how do we know? So para mailagay natin si point P sa circle, then we have to show, it is enough to show BCPQ is an isosceles trapezoid. Okay. So, okay, ganito. QP parallel siya sa BC. So definitely, BCQP, alam natin BCQP is a trapezoid. All right? But a trapezoid is not necessarily isosceles. So to make this cyclic, we have to show isosceles siya. So that would mean showing. So we have to show BQ and CP are congruent. Can you, paano kaya yun? BQ and CP congruent.
Okay. So if they're congruent, then BH is the same as BQ, which is already proven.
Yeah. But then BHCP is a parallelogram.
Yes, okay. So BP is wait. Okay. BH congruent to CP and CP congruent to BQ. HMMP. Wait.
Actually, yun na. BHCP is a parallelogram, right? So therefore, what can be said about BH and CP?
They are congruent.
Ayun. So that's it. CP equals BH, but BH equals BQ. So therefore, BQ and CP are equal.
Bro? Nice.
Again. So get small, or I mean, of course, I'm gonna write it down. So anyway, BQ and CP are equal, and then Q, and then you have, that means your trapezoid is really an isosceles trapezoid. So therefore, the vertices BCQP are concyclic, which means P is on the circle of BQC. But that circle is a circumcircle. So yun na. Yay. Okay.
My force win.
All right. So note that BHCP is a parallelogram. So now we have.
na-notice ko pa lang po ngayon. Bakit halos hindi po gumagalaw yung mouse niyo po and yet you're simultaneously writing?
Hindi gumagalaw ng mouse ko. Alright, kasi the mouse is controlled by two devices. The mouse itself and the pen. So nung pen, if ilapit ko siya sa tablet, it takes on the role of a mouse.
Mm.
Ayan, so may dalawang nagko-control. Okay, so you have CP equal to BH. And what's the reason for that? It's because BHCP is a parallelogram. But then on the other hand, BH is equal to BQ. And the reason for that is because H and Q are reflections of each other with respect to BC. Okay.
Monoflexion.
H and Q are reflections of each other with respect to the side BC. And so from CP equal to BQ, along with the fact that BC and QP are parallel, since CP equals BQ and BC is parallel to QP, then BCPQ is an isosceles trapezoid. So it is cyclic. Thus, P is on the circumcircle of triangle ABC. Okay, P is on the circumcircle of triangle ABC. Ayan. All right. So that means, yun nga, the reflection of H with respect to the midpoint M is definitely going to be on the circumcircle.
Nice.
Nice. Yuppers. Yep.
Nice.
Okay. So I was thinking about that in terms of this particular problem. Okay. Akala ko makakapunta na tayo dun sa ibang mga... Okay lang, we were wrapping up. Naman kasi binalikan lang natin to. Pero ito, back to this problem. Show that A, O, and HD are going to be parallel to each other. But let me add another problem. This is not this is not a homothety exercise, but I'd like to take advantage of the discussion that we just wrapped up. So ito, nung claim number 2 essentially. So ito, because I've seen this occur a lot of times. So here's the situation. So let triangle ABC have in center I. Well, I mean, it's a standard notation naman talaga, have in center I. Let ray AI meet the circumcircle of triangle ABC again at point L. And then let L sub A be the reflection of I over or with respect to L. Okay. Okay. Prove. Okay. I, B, C, and IA are concyclic, so they lie
No.
on a circle with diameter. Wait, sorry, not I sub
How is
A,
this
but
possible?
L sub
Ano, I
A,
sub A.
the reflection. Lie
Okay.
on a circle
Kala ko
with diameter.
ma-freak out na po ako kung I sub A.
Lie on a circle with diameter I and then L sub A and center L. Okay. And then this is the first part. Second part. Okay, mamaya na. I-drawing muna natin ng configuration. Okay. So ABC and then in center I. That let AI meet the circumcircle of ABC again at point L. Okay, so well, let's draw this circle. Of course, the center of the circle is not I. Okay, it would be
Anorexic.
it would be whatever the okay. Ayan.
I think it
So
should be a
that
little, it should gain a little more weight.
okay, sige. Uh,
Yan. Yun na po.
ayan. All right. So that will do. So this would be L. Prove and then what's L sub A? Wait, hold on. Actually, oh no. Ito dapat nung L sub wait L. Okay. So ABC in center I. Let the ray AI be the circumcircle of ABC again at L, and then let L sub A be the reflection of I with respect to L. So ibig sabihin, itong length ng IL, dodoblehin natin or i-copy over here to the other side. L is the midpoint, and then the result is going to be L sub A. Show that I B C and L sub A
Di ba po may
are
parang, di ba parang may DeLongchamp's point? Na DeLongchamp?
I think I've heard of that term, but I'm not familiar.
But it's
Okay.
sort of like that, but it is the circumcenter instead. Maybe we could use that po.
Okay, but if you're gonna use that, I would like you to justify that. Because this appears to be something that can be proved from first principles. So parang ano, gamitin natin so far, parang yeah, no geometric knowledge that we have gathered. Okay. Well, I So what's relevant here is that the diameter is ILA, and then mentioning that the center of the circle is L is redundant because L is the midpoint of ILA. So therefore, if ILA is the diameter, so that would make L the center. So basically what we gotta do is show that well, to show that it's a circle and then the center is provided, you could show that LB, LC, LI, and LLA are all congruent. So like I said, their common value would be the radius. Okay, so that's how you can show I, B, C, and LA are cyclic, and L is the center by showing those four green segments are equal. So you already know LI and L sub A are equal, but of course LB and LC, that's a different matter altogether. But this gives us a clue kasi, well, di ba, I is in center, so that makes this angle and this angle the same.
Opo.
So that means itong arcs BL and LC, they have the same measure. So that makes the chords BL and LC congruent. Alright, so we already know BL equals LC are equal, and then LI and L sub A are equal. So check. Ang question na lang, how do you connect those pairs of congruent segments? How do you know that they're all congruent? So that's the gap. Okay, but I am not done yet. Number 2,
Cyclic quadrilateral.
show that L sub A equals I sub A.
Funny green box moment.
Show that L sub A is actually the yeah, it's actually the AX center. So remember,
What?
AI and the
No,
AX center are
this is even another way to draw the.
yeah.
Oh,
Yeah, actually, once you have the in center, so extend it until it meets the circle here at point L, and then extend it. Tapos figure out the reflection of I with respect to L. That's gonna be the so kaya kanina tatanong mo nagkamali ako. Instead of L sub A, I wrote down I sub A, but that's because of number 2. L sub A is gonna turn out to be the AX center.
Funny spoiler alert.
Oh.
Spoiler alert, spoiler alert.
But it appeared like I just made a mistake, but actually it was really
L
that.
sub A looks rather similar to it looks rather similar to I sub A.
So how can we show that L sub A is the AX center? Well, because I'm gonna let you figure it
Me after homosity.
I'm gonna let you figure it. Actually, this, as much as you can argue it's using a homosity, but I can see an argument which does not use a homosity.
Homosity.
Okay. Okay. Hey, so I hope it's alright because I already scheduled a 5 p.m. meeting. So ayan. Anyway, so you and Joshua have problems to work on.
Nasaan na siya?
Alin. So this is in the actually dinagdag sa September 28 but dito sa October 2022. So meron pa. Although ito lang ang nabigay kong homosity problem. What about, hold on. Parang kulang eh. Let me write another homosity.
Oh no.
Well,
Panadagdag.
Okay. Another one.
No!
It's also nice. But it gives you options kasi kung kunwari, mahirapan kang isolve yan, tapos itong second na isusulat ko, mas madali pala, edi,
Green. Dapat
uh,
po yung triangles na po must be to scale with the actual triangle.
alright, alright. So given, okay, triangle A, B, C, and then, okay, the usual centers, I and O. In center and circumcenter. Okay. Let D be the circumcenter of
The
okay triangle BIC. And then EF are respectively the circumcenters of the following triangles AIC and AIC.
CIC. I mean AIB.
I mean AIC is the same as CIA naman. CIA.
The Central Intelligence Agency.
AIB. So yun lang, para nung tama ng mga phrase.
So I found out. So you can prove po that the letter E is the center of the Central Intelligence Agency.
Yes, of course. All right, gotcha. There. All right.
The center of
Let P, Q, R be
4 points.
the midpoints of segments DI and then EI and then FI.
May ano po yung tawag po dito sa problem na ganito po yung may routing po. Yung this point is the yung define na po is this. And then this other point is the definition that uses the newly defined points. And then so on po. May tawag po dun eh. Definition yata po. There's a term yata po.
A carefully written problem. A problem written with lots of love. I think that's what it's called. Prove that the
Very passionate problem.
Okay. The proof that the circumcenter of triangle PQR is the midpoint of IO. Ayun o, meron tayong
So
tatlong
finally, it is like it is the 9-point center, but it is of the in center and circumcenter.
yes, right. Also, you have 3 collinear points.
There must be a name for this po because it's the midpoint of I and O.
Okay. So, all right, I'm gonna let you figure this out, draw it on your own. I'm sure you could draw it. So, all right, at this point,
I don't have the capacity po to draw it.
Of course you do. You're gonna have fun. All right. Okay. I have to take my leave, and good afternoon, both of you. Bye.
Bye-bye po. Thank you po.
Thank you po.
Bye-bye po.